Hey there, all of my Algebra 2 Trig peeps. We are going to be working on our final exam review packet. So what we're going to do is do this a chapter at a time. This video is going to cover Unit 4. So the first thing that you have to do for number 1 is write an equation. So we're going to start by f of x is equal to, leave ourselves a little bit of room, and we have a square root symbol. Vertically stretching by a factor of 2 means we multiply out front by a factor of 2. 4 units to the left. Remember, when you're going left and right, it's opposite of what you think inside. So left you would think is -4, but it's actually +4. And then your up and down, your vertical translation is on the outside. Down 3 would be exactly how you think it is down 3. So to graph it, well, if you're smart, you're just going to type it in your graphing calculator, press the table, and you should get some nice pretty points. And those nice pretty points should be the ones that I've just plotted for you. Now, you just want to sketch, arrow going that way, but it never goes past -4. And there's a reason for that, because then we'd be taking the square root of a negative, which we are not allowed to do. So now we're just going to state the domain and the range. So the domain, remember, is x. X never goes past -4. So our domain is x has to be greater than or equal to a -4. Our range is our y value. And we notice our y never goes below a -3. So y has to be greater than or equal to a -3. That's it for the first one. Next question is a cube root. So how are you going to graph it? The exact same way you just graphed the last one. You type it in your graphing calculator, and you plot as many pretty points as you can. So transformations, we're going to vertically stretch it by a factor of 3. And we are going to translate it right 2 and up 3. So remember, opposite of what's inside is your right and left. And then this is your up and down. So we're going to start at 2, 3. But again, you're just going to type this in your graphing calculator, and you're going to get your own good points. And like I said, just use the table and you'll be good to go. So after you plot all of your good points, you're going to sketch a graph. A cubed root, remember, goes forever in both directions. And that's because we can take cube roots of positive and negative numbers, but we cannot take square roots of negative numbers. That's why he only went in one direction. So for this one, the domain, x is equal to all real numbers, and your range is y is equal to all real numbers. And it always will be that way for odd roots. Okay? Performing operations. F of x times g of x is just a simple multiplication. So we have 2x to the 2/3 times 3x to the 1/2. So back in the day, whenever we multiplied, you still multiply the numbers. But when you have variables with exponents, you add them. So 2/3 plus 1/2 is going to be 7/6. So this is 6/6 root of x to the 7th. And then you have to simplify a radical. 6 does go into 7 once with a remainder of 1. So we simplify this to 6x times the 6th root of x. So that is performing the operation. Now we have to state the domain. So remember, domain, in this situation, x is allowed to be anything except a negative number, because we can't take even roots of negatives. If this was an odd root, it would be fine. So our domain is x has to be greater than or equal to 0. Okay? Number 4. This is very similar. We're just dividing. So we have 2 x to the 2/3 over 3 x to the 1/2. And the 2/3 does not simplify at all. If it did, we would. But now remember, when you divide, you subtract the exponent. So 2/3 minus 1/2 would be 1/6. So once we simplify that guy, we have 2 sixth root of x all over 3. So that's our simplified part. Now we have to do our domain. So again, we cannot take the even root of a negative. But going back here, you cannot divide by 0. So you can't divide by 0, so x is not allowed to equal 0 either. So it has to be a positive, so x has to be greater than 0. Last example. So this is when you substitute a function inside of another function. So we're going to make m red, and we'll do n blue. So what we're going to do is set up our m on the outside. So x squared minus 2 times x plus 3. That's our function m. And then we are going to substitute n of x into it. So x is now x minus 2. And x again is now x minus 2. And that's all you really need to do for the first part. After that, it's just simplifying. So we have x minus 2 times x minus 2. And that's going to give us x squared minus 4x plus 4. Then distribute your negative 2. Negative 2x plus 4. Then plus 3. And after we work with that, simplify it, we're just going to have x squared minus 6x plus 11. Our domain for this is easy because we can square anything and we can substitute anything in. We have no restrictions, so our domain for this is x is equal to all real numbers. Okay? Moving on. The next thing we're going to do is solve. So when we're solving with radicals, first thing you want to do is get the root by itself. So we have the cube root of 6x minus 5, which is equal to a negative 3 after you subtract the 10 to the other side. And now you have to cube both sides. Well, that's going to make this part easy because this is now just 6x minus 5, and that's equal to a negative 3 cubed would be a negative 27. Be careful when you type that in the calculator. And add 5 to both sides, so 6x is equal to a negative 22. Divide both sides by 6, so x is equal to a negative 11 thirds. Done. The next example is just a little bit trickier because we're all ready for squaring to get rid of our square root. So we have 8x plus 1, but that's equal to, you must FOIL that. X plus 2 times x plus 2 is not x squared plus 4, it's x squared plus 4x plus 4. So make sure you FOIL. Get everything over on one side, you'll have x squared minus 4x plus 3 equals 0. Factor, you get an x minus 3 and an x minus 1. And that's going to give us x is equal to a 3 and a positive 1. Now remember, for all of these, you're supposed to double check to make sure that your answers work. And if you substitute in a 3, you'll get 24 plus 1. The square root of 25 is 5. And 3 plus 2 is also 5, so 3 works. Do the same thing with 1, and 1 will work as well. But sometimes one of them doesn't, so always make sure you check. Last 2 questions for Unit 4. And then we'll make another video for the rest of them. Finding inverses. Remember, the first thing you want to do is switch your x and y. So x is equal to y to the 5th power plus 2 all over 7. And then you just solve for y again. So get rid of the 7 in the denominator by multiplying both sides by 7. So 7x is equal to y to the 5th plus 2. Subtract 2 from both sides, and you have 7x minus 2 is equal to y to the 5th power. And then take the 5th root of both sides, and you will have your inverse is equal to the 5th root of 7x minus 2. Leave it alone, you are done. And last one for this review. It's very similar. Start off by switching your x and y. So we now have x is equal to 3 times the cubed root of y minus 1. Get rid of your 3 by dividing both sides by 3. So we have x over 3 is equal to the cubed root of y minus 1. How do you get rid of a cube root? You have to cube both sides. So that's going to give us x cubed over 27 is equal to y minus 1. So we just have to add 1 to both sides. So our inverse is equal to x cubed over 27 plus 1. Do not just add the plus 1 to the top, because that would not be correct. Because 1 would be like adding 27 over 27. So if you wanted to, you could call it x cubed plus 27 over 27. But either one of those work out just fine. So you pick your favorite and you're good to go. All right, so that's a little video of your final exam review for Unit 4. This is Longo and I'm out. See you, bye.